Now that we know what equivalent equations are, we're going to talk about how to create equivalent equations. All right, so in this video, that's what you're going to learn, how to create equivalent equations. All right, so quick reminder, our last video we talked about this, that equivalent equations are equations that have the same solution. Okay, and here is the basic idea of this video right here. Right? If you have an equation, you can create a new equation that is equivalent to the first equation by performing the same operation to both sides of the equation. Okay, let's think about that, process that, right? So if you start out with some equation, right, you can create a new equation that will be equivalent to your first equation if you perform an operation, the same operation, to both sides of the equation. All right, let me show you what I mean. All right, so let's take a look at this example, right? So I have this equation, x plus 3 equals 10, and this is a pretty simple equation, so you can probably already tell what the solution is. Right? What the solution to this equation would be 7, right? Because 7 plus 3 is 10. 7 is the number that makes that true, right? And so what we're going to do is we're going to create some equivalent equations. Okay, so let's create a first one by, let's say, let's add 4 to both sides. Right? Let's perform the same operation on both sides. So my original equation was x plus 3 equals 10, and let's add 4 to both sides of the equation. Right? X plus 3 plus 4, that's the left side, and then the right side we have 10 plus 4. Right? So what do we have now? We have the equation x plus 7 equals 14. Right? So all I did was I added 7 to this side, or I'm sorry, I added 4 to this side, and then I added 4 to the right side. Right? And so my new equation is x plus 7 equals 14. Right? So is this equation equivalent to our original equation? Well, the answer is yes, because the original solution was 7, and 7 is still the solution here, right? Because 7 plus 7 equals 14. Right? So this equation is equivalent. Right? And you can do this however you want, right? But the basic idea is the same. Right? Let's say I have this equation, x plus 3 equals 10. Well, let's create another equivalent equation. Let's create an equivalent equation by, let's say, subtracting 5 from both sides, right? So let's see, I have x plus 3, and let's subtract 5 from the left, and let's also subtract 5 from the right. Right? Well, if I were to simplify the left-hand side, x plus 3 minus 5, that simplifies to be x minus 2, and the right side, 10 minus 5, simplifies to 5. So here's a new equation, x minus 2 equals 5. Is this equivalent to this? Well, the answer is still yes, because 7 is still a solution, right? 7 minus 2 is 5. That's true, just like 7 plus 3 equals 10. So as long as I do the same thing on both sides of our equation, I still end up with an equation that is equivalent to the first equation. All right, so let's take a look at this equation. Okay, 8 minus 6x equals negative 4x minus 2. All right, the solution to this equation is 5. Here's what we're going to do in this example. We're going to create an equation that's equivalent to the original equation by dividing both sides by 2. And then we'll check to just to be sure that our new equation is equivalent to the original equation. Okay, there's kind of a lot of information here. So let's kind of go back. The first thing I said was the solution to the original equation is 5, right? And you know, just in case you don't believe me, let me just kind of check over to the side here, right? So we had 8 minus 6x equals negative 4x minus 2. Right? So just in case you don't believe me, let's see if 5 is the solution. So if I were to input 5, would this be true? We would have 8 minus 30 equals negative 20 minus 2. 8 minus 30 is negative 22. On the right-hand side, negative 20 minus 2, that's negative 22. All right, so yes, indeed, 5 is a solution because it made this equation true. Okay, that's just a kind of side thing. All right, let's go back to our original problem. So we want to create an equivalent equation by dividing both sides by 2. All right, so let's do that. If we were to divide both sides by 2, what would happen? Right? So we need to take the left side, 8 minus 6x, divide that by 2, and then take the right side, negative 4x minus 2, and divide that by 2. Right? Well, let's think about this. 8 minus 6x divided by 2. Right? That would be 4 minus 3x. Right? Remember, there's two pieces here, 8 and a negative 6x. I'm dividing the whole side by 2. Right? So both of these are going to be cut in half, 4 minus 3x. And then over here, negative 4x minus 2, if I divide this whole thing by 2, right, I would end up with negative 2x minus 1. All right, so here is my equivalent equation. All right, so do you believe me? Is this equivalent to the first one? Well, how do we check? If they're equivalent, they should both have a solution of 5. Right? And I already showed you that the first one had a solution of 5. Let's check this one. If 5 really is a solution, it should make that true. Okay, let me do this off to the side here. So 4 minus 3 times 5 equals negative 2 times 5 minus 1. So this is 4 minus 15 equals negative 10 minus 1. 4 minus 15 is negative 11. And on the right-hand side, negative 10 minus 1 is negative 11. That is true. Right? So 5 is still a solution. Okay, so as long as you do the same thing on the left and the same thing on the right, your new equation will be equivalent. It'll have the same solution. Okay, you're going to do this one. Same idea. The solution to this equation here is negative 4. If you want, you can check that, but believe me, the solution here is negative 4. You are going to create an equation that's equivalent to the original equation by subtracting 2x from both sides. And then I want you to check to make sure your new equation is equivalent. All right, so you're going to do this one. So please pause and work this out. All right, hopefully you were successful. So let's see what happens. We're going to create an equivalent equation by subtracting 2x from both sides. So if I were to subtract 2x from the left, I would have 9 minus 5x minus 2x. And then I'm going to subtract 2x from the right. Okay, and let's go ahead and simplify this. 9 minus 5x minus 2x, that's 9 minus 7x. How about the right side? 29 minus 2x. You know what? That can't be simplified. That's just 29 minus 2x. All right, so here is the equation you should have come up with. This is the equation that's equivalent, right? And if you don't believe me that this is equivalent, right, you should have because you checked your work, right? Let's see if negative 4 makes this true. Let's do that off to the side here. 9 minus 7 times negative 4 equals 29 minus 2 times negative 4. Okay, so this is 9 plus 28 equals, this is 29 plus 8. Right? This would be 37, and this side would also be 37. It's true. Okay, so negative 4 makes this equation true. Negative 4 would have made the original equation true, because negative 4 is solution to both, because both of these are equivalent equations. All right, last thing. This is our you try it. So this you are going to do on your own, and I will check this in class. Okay, you are going to create 3 new equations that are equivalent to this equation here. Okay, so x minus 8 equals 6. This is our starting equation. This is our original equation. And your job is to show me tomorrow 3 new equations that are equivalent to this. Right? But you're going to follow these specific directions. For the first equation, you're going to start with this equation, and you're going to add 5 to both sides of your original equation. The second equation, you're going to start with your original and multiply both sides of your original equation by negative 3. The third one, you're going to take your original equation and then divide both sides by 2 for your new equation. Okay? So tomorrow in class, I'm going to check your paper, and I should see these 3 new equations that are equivalent to this one. See you in class.